You look up at the night sky and it's just staggering. Every single one of those little lights is a sun, right? And so many of them probably have planets just like ours. Some of those planets are bound to be like Earth. So with all that out there, all that possibility, it really makes you wonder, where is everybody?
And that one simple question, that's the heart of what's called the Fermi paradox. It is honestly one of the biggest, most mind-bending mysteries in all of science. Because when you start to actually look at the numbers, you realize something just doesn't add up. So let's just start with a number that's almost impossible to wrap your head around, 25 billion. That's a conservative guess, by the way, for how many Earth-sized planets in the habitable zone exist right here in our own Milky Way galaxy. I'm not even talking about the whole universe, just our backyard, 25 billion.
Which leads us to this really unsettling silence. I mean, the universe is incredibly old, it's huge, and statistically it should be absolutely buzzing with life. But when we point our telescopes out there and listen, we get nothing. Total silence. This whole contradiction was perfectly captured way back in 1950 by the physicist Enrico Fermi. He was at lunch talking about aliens, and he just cut through all the noise and asked, "Where is everybody?" And this right here, this really lays the problem out in black and white. The universe has had almost 14 billion years to get things going. Our galaxy alone has over 100 billion stars and, like we said, around 25 billion potentially good planets. Think about this. A civilization just a million years ahead of us, which is nothing in cosmic time, could have spread across the entire galaxy by now. And yet the official count of detected alien civilizations is a big fat 0. Now, to really get a sense of what we should be seeing, you gotta know about the Kardashev scale. A Type 2 civilization would be so advanced it could harness all the energy of its home star. We'd probably see some kind of giant structure around it. A Type 3, they'd be harnessing the power of their entire galaxy. These wouldn't be subtle. They'd be like cosmic lighthouses. And the fact that we see none of them, not a single one, that might just be the most powerful clue we have in this whole silent mystery.
Okay, so how do we explain this silence? Well, let's get into the first possible solution. And I'll warn you, this one is probably the most terrifying. It's an idea called the Great Filter.
So the theory goes like this. Somewhere on the long road from simple life to a star-hopping civilization, there's a wall, a barrier, a filter that is so incredibly hard to get past that almost nobody ever does.
And this brings us to the really chilling part of the whole idea. Where is this filter? Is it behind us, or is it still waiting for us up ahead? See, if the filter is behind us, that means that we're incredibly special. It means that becoming intelligent life is a near impossible fluke, and we're one of the first to make it through. But if the filter is ahead of us, that suggests that intelligent species almost always wipe themselves out before they can colonize the stars. And that would mean we're not special at all. We're just next. All right, if you thought that was dark, let's talk about another idea. This one comes from science fiction, but a lot of scientists take it very seriously. I want you to imagine the universe isn't empty space. Imagine it's a silent, dark forest at night. So in this forest, every civilization is like a hunter, moving silently, trying not to be seen. You can never, ever know the true intentions of another hunter you meet. Are they friendly, or are they going to take you out to get rid of a potential threat? When you're faced with that kind of uncertainty, the only surefire way to survive is to stay quiet and to eliminate anyone else you stumble upon before they can do the same to you. So the silence of the universe, it's not emptiness, it's terror.
And here's the kicker. Since the early 1900s, with our radio waves and TV signals, we haven't been hiding at all. We've been doing the exact opposite. We've been lighting a giant bonfire and screaming our exact location into a dark forest that we know absolutely nothing about.
Okay, let's step back from the scary stuff for a minute and look at a different possibility. It's a bit more wondrous, maybe a little lonely, but not quite so terrifying. What if the reason for the silence isn't that life always gets destroyed, but that it's just exceptionally, unbelievably rare to begin with? This is what's known as the rare Earth hypothesis. The idea is that for a planet to produce intelligent life, you don't just need one thing to go right. You need a whole long list of things. You need the perfect kind of star in a safe part of the galaxy, a big moon to keep your planet from wobbling, a giant planet like Jupiter to act as a bodyguard, and even the right kind of geology to keep the climate stable. When you add it all up, maybe we're not late to the galactic party. Maybe we're the ones just starting to set it up. But what if we're not alone? What if we've actually heard a whisper in the silence? Back in 1977, a radio telescope picked up this incredibly strong 72-second-long signal coming from deep space.
It was exactly the kind of focus signal you'd expect from an artificial source, not a natural one. And then it just vanished. The astronomer who found it, a guy named Jerry Ehemann, was looking at the data printout. He was so blown away by how perfect the signal was that he just circled it in red pen and wrote one word in the margin. Wow! And for more than 45 years, we have never, ever heard it again. It is still the single best piece of potential evidence for alien contact we've ever had.
All of this brings us to a quote from the science fiction master Arthur C. Clarke, and I think he just nails it. Two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. When you really stop and think about it, the implications of either answer are just absolutely world-changing.
So in the end, the Fermi paradox is really like a giant mirror. Maybe the big question isn't just where is everybody else? Maybe the real question that this cosmic silence forces us to confront is who are we? Are we just a cosmic fluke? Are we a brief flash of light right before the filter gets us? Or are we the only ones here, the keepers of the only consciousness the universe has ever known? The silence gives us no easy answers, but it does tell us one thing for sure. Our future is incredibly precious, and it is completely up to us.